I'm in a small group today. I know we have some classes running, so we're recording the session. So thank you to the people who are here, and we'll have more sessions later for MEng and for research-based programs split into two. So for now, thank you all for coming. We'll have a few people from the university. Sorry, I'm supposed to go close to the podium because this is where I record. We'll have a few people from the university and our department here to welcome you and give you some information on a few of the key things you might want to know starting your program. So first, we'll have a brief introduction from Lisa Altman Hall, who's the chair for our department.
Thank you so much, Anna. So there's not very many of you. So how many of you are master's students? Okay, and are you all in the MEng or are you in a research master's? MEng, everybody MEng? Research, working with who? So faculty that are in different departments. Yeah, so that was what I decided was the one thing I would say in my couple of minutes Anna gave me. I apologize, I have a conflict, I can't stay. But I've been the chair of the department for this, I'm going into my 4th year, and I love this department. And so, you know, one thing that's kind of weird about being a graduate student is that all of your faculty have at one point been graduate students. And so they remember the really hard things and they remember the really great things. So you're sort of surrounded by people who want to mentor you to help you maximize those great things. And the cool thing in our department is really this interdisciplinarity. Like all of you have decided you want to like study, you know, something about engineering in more depth. And every type of engineering is kind of majority built on a different type of fundamental science. So if we think about structural engineers, right, physics is very important to them. If we think about the environmental engineers that treat pollutants, chemistry is very important to them. If we think about mechanical engineers, physics is very important to them. If we think about electrical engineers, Eric, help me out. It's also physics, right? Physics is important. But for me, as a studier of travel behavior in the transportation system, actually the fundamental math and science that's most important is actually statistics. Some of the data science stuff, really, really important, especially in this age of big data. So in this department, you're going to find faculty and fellow students who kind of have a huge diversity of fundamental science that underlies the design that they do in their particular type of system, whether it's biomedical or mechatronic or societal environmental. And so I just want to invite you to sort of use this time in grad school. Like it's a really special time in your life focused on learning, like maybe a focus on learning like you'll never get again in your life, and reach out beyond your group, beyond the people in your classes, come to the great activities that Anna plans, and reach out to those other people who are studying something in grad school in a really focused way, who might be doing something completely different from you. Because you just, you know, when you get into the professional world, and the hubbub of life, and some people choose to have children, some people choose to be long distance commuters, you're not going to have that time to just walk across the room and say, what? You're working in Professor McPhee's group? What are you doing? What type of research questions? Like what's in that course? So take that opportunity and enjoy it. And if you find yourself bumping into something that has to do with transportation systems, that's when you say to yourself, wait a minute. I know that the chair of this department is the biggest transportation system geek in the world. No matter what it is, an airplane, a bus, a bicycle, a pothole, she probably would be willing to brainstorm with me and give me some guidance. And that's when you send me an email and you say, I didn't expect it, Dr. A, but I'm bumping into a transportation system thing in my research. Can you point me to something? And I would be happy to do that. I can't always reply to emails same day, but I'm pretty good, right, Eric? I'm not as good as some people, but I'm pretty good. So I invite you to get engaged with everybody from the chair of the department to the person sitting next to you in your lecture, and just have a wildly great time. It's my understanding that I have the honor of being the first coffee chat guest next week, where I'm gonna drink coffee with you and talk about my experiences. in grad school, which was a really long time ago. So we'll also talk about how your experiences are different. But I did spend a lot of time in the US, and I know the Canada-US contrast is important to some people if they plan their lives and careers, and you can consider me a resource there. So welcome, welcome, welcome to this really special department, and thank you for being here at this session. I look forward to seeing you at more things.
Thank you. Please, now we will have Ehab Abdul-Rahman, who is the Associate Chair for Graduate Studies, and so you will likely interact with him at some point in your careers. Thanks, Ehab.
Thank you. Good morning. Ehab. Just let's agree on the division of work. If you have any questions that have to do with your academics, it comes to me. If you have any question that has to do with procedures, process, paperwork, what goes where, forms, it goes to Anna. Because I don't know. Oh, that's true. Okay. So you want good guidance on both sides. Okay. Almost all of you are new to the department, so welcome. We are hoping also to get some of the old guys and ladies showing up later in the day, so you might see them as well. One thing you would observe is it can be solitary. Because most of you are Master of Engineering, so you don't have research groups. That deprives you of support group of people who have been here for some time, who know their way about. But that's what the department is supposed to be doing, and that's why we have regular functions. And there is a graduate student association department that is more active now. We do support it and would like it to continue to be active, and that's for you. It would be quite useful for you to engage with GSA and with these social activities, because it will give you some support, some structure, and you need to get to know your way about not just the buildings, but the programs and the procedures. Especially with Master of Engineering, you need to do some planning about when do you take what, because the offerings are sometimes patchy. And if you want to take specific specialization, it could get tricky. I have an idea about future programming. I could answer questions about that. And I can, advise you about, we'll talk about that in a minute, about our programming as well. So you need to plan ahead, and you need to think about talking to people and getting to know people. What we're going to be doing today are two things, getting you a forum which you can get to know each other, and passing some information for those who are new to campus about processes, procedures, and the like. So we have a presentation, right? Okay. What do I click? Okay, good. So yeah, so that's the agenda. I'm speaking now. I'll be followed by Andrea Millen on the library and the resources the library can offer, especially if you're going to be writing. And you're going to be writing, even if you're not writing a thesis, you're going to be writing projects and reports. Eric in the back is going to be talking about the health and safety. Eric is the our chief of operations department. And our safety office is has a dim view of us, so we better stay on its good side. Asherbad is going to be talking for the GSA, and then we'll have the representative for wellness programs. Okay. So Anna is in charge of the research programs. We're going to be hiring someone new soon to be in charge of the Master of Engineering programs, and I'm in charge of academics. The department is growing. We used to be, not very long time ago, about 20 faculty. We're now 35 and growing. We should be about 40 soon. We have a lot of professors who are associated with us either through an adjunct appointments, and those tend to be in industry, or cross appointments from other departments. Because we're interdisciplinary, many of these are not even in engineering, which we consider to be a good thing. As long as what you're doing is engineering, that's your natural home. The student body right now is about 250, and that's about 70 or 80 Master of Engineering, 70 or 80 Master's Science, and the rest are PhD students. We actually offer officially 3 degrees, but the Master of Science and PhD come in 3 flavors: plain, nanotechnology, and aeronautics. As I earlier said, the characteristics of what we're doing here is, as long as you are trying to engineer some system that is, built and operated for profit or for value, then that's your home. It shouldn't. Well, the only exclusion is if it fits very nicely somewhere else in engineering, then it's probably not here. I mean, if it's strictly grease, it's probably mechanical engineering. Okay, these are the rules and regulations on the programs. So the comparison here that you might want to keep in mind is the total number of courses. Master of Engineering is at 8, Master of Science is at 4, Aeronautics have an additional course, Nanotechnology is also 4. Specializations are a bit tricky. So the way it works for Master of Engineering, if you take the required courses, you're automatically in the specialization. For Master of Science and PhD, it's a question of agreement between the professor and the student. So they declare their field, and the examining committee ratifies it. The fields we study are usually 8, but simply put, there really are 5. There is biomedical, there is mechatronics, and what we call physical systems, things that tick. There is human factors, there is vision and image analysis, and there is artificial intelligence and machine learning. The PhD programs are similar. The difference is just in the number of courses. So although the numbers here are look very confusing, it's simple. The PhD only are required to take 3 courses. Aeronautics have an additional course, 4. The larger numbers you see, 7 and 8 and 7, these are for direct admission to PhD from bachelor. You can't actually apply to PhD from bachelor. It has to come at the recommendation of the faculty, and it's not something I recommend. So I won't talk a lot about it. And the same rules apply. Master of Engineering is not funded. Master of Science is officially funded, but it's not really funded. PhD is funded. That's all I have to say. Any questions you'd like to ask? Yes. No, I didn't see you. I comment on. I said that you can do a specialization, so you don't have to. So actually, we have. If you look at Master of Engineering, we have 6 types of Master of Engineering. There is the plain Master of Engineering with system design, and then there are 5 specializations. If you look at the website, it will tell you that if you want to get a designation of this specialization, take these courses, and it's automatic. So you don't need to declare anything. It has to do with your career, whether it's better or not to do a specialization. It has to do with your career goals. So if you think that it would make it easier for you to get the kind of job you're looking for, if you have system design dash something, yes. If you think it would make it less flexible, no. Okay. There are advantages and disadvantages. So if it says mechatronics and you're looking for something in software, no. On the other hand, system design is reasonably known brand in Canada, and means that this is someone who's flexible, who can do engineered systems of different varieties. Okay. The going to specialization also means that you need to take specific courses, and these show up in the calendar at specific times. So that takes management, and sometimes luck, because sometimes we can't offer a course because those who teach it are all in sabbatical. It does happen. Yeah. We have something like that in a few courses currently.
Let's find that a little.
Remember that you can take courses outside systems as long as they are engineering, and I will approve courses outside engineering as long as they are relevant to engineering. Okay, where I object is if they are not relevant to engineering, or if there is an identical course in systems that is being offered. Okay, but we do encourage students to learn and to to create their own programs and pursue their interests. That's good. Yes. So the question is, if you want to take a course but you don't have the background, can the department do something about that? No, because that is up to the instructor first. Two, if you don't have the background, what you could do is you can take another course to prepare for it. So that typically should be a 600 course that you don't have the background for, and then you can actually have a 500, take a 500 course. You can take up to 500 courses, 500 level. So that would prepare you for it. So but you need to be to plan ahead. Okay, because then you will have to take a 500 course, then 600 course. Master of Engineering students typically have a span of 3 to 4 terms. So that would take some planning. Okay. So your question is, do you need to go to the instructor to see what are the necessary materials to take before taking the course? Yes. The instructor is the one who, we have a course description in the calendar, but in the end, the instructor is the one who defines the level at which they teach. So that would define what kind of requirements they need. Okay. Some instructors could have a leeway to accommodate people who do not have as much background. Others may not have that leeway. So best placed is the instructor themselves. The course might not be on offer this term, but I know who is likely to teach it and who has taught it before, and those are the people who will tell you. Okay. Yes. So that's a procedural question, and I know it's tricky. So the question is, can you take more than 8 courses? And I would answer that.
In that year as well. So you'd be able to squeeze an extra course. You're also able to audit courses, and they count towards your overall course load, but they don't count towards your degree requirements. And you can take courses as extra to degree as well. And so those are courses that would count towards your degree requirements, but that you still might want a numerical grade on your transcript. And so those require you to fill out a course adjunct form, which you talked to me about. And so that's an option as well if you're interested in taking courses sort of outside your scope of study.
Thank you. One advice that's academic now. For those of you who are starting a graduate career, a graduate course is not equivalent to an undergrad course. Graduate course is equivalent to about 2 undergrad courses. So full load is somewhere between 2 to 3 grad courses, depending on how heavy is the course and how workaholic you are. Okay, but I won't ever approve more than 3 courses. It will require approval, and I'm not approving it. Because it either means that you're going to kill yourself, or you're taking courses that have no workload. And both are not acceptable. Okay. But you know, you should expect that this is significant going. So actually, and that's what you are in grad school for, to go in depth into material. Okay. Any other questions?
The sections that we'll have starting in London. So if you haven't come up with any other questions, then we'll have lots of time to answer them.
One note to those who are doing Master of Engineering: if you're interested in moving sideways to the research program, you may talk to professors. So we have significant issues with our Master of Science pipeline because the funding level is too low, and that means that our admit rates into the Master of Science are lower than what we'd like them to be. And frequently, some of us have need to hire or recruit on a very short notice. We look into the Master of Engineering pool. If you're interested, you may not be interested, and that's your career choice. Thank you.
We got the schedule a little wrong on that first slide, and we'll actually be speaking with Eric next, who is our lab director and the safety representative for our department. And so he's going to speak a little bit about staying safe while you're working in labs or just generally within the department. There you go. Thank you, Eric.
Well, even though I didn't put my name on the slide here, my name is Eric Kubica, and I'm the lab director in the department and the safety coordinator. Just from some of the things that were said, and because this is a little more intimate group, I'll tell you just a little bit about myself. I did my bachelor's in mechanical engineering, and maybe like some of you, when I finished my bachelor's, I actually didn't feel like I knew that much useful material. And so I went to grad school and I did a master's in mechanical engineering. And after that, I switched gears radically, which sort of fits with one of the questions that you asked back there. So I went from mechanical engineering. I did an interdisciplinary PhD in electrical engineering and applied health science. So it was radical departure from what I was doing before. And there were a whole bunch of courses I had to take that I did not have the background, because in those two disciplines I was studying, other people in those disciplines had a whole undergrad degree in it. So can it be done? Yes, it's more work and it's hard. There's there's two extremes to getting through grad school. One is you can be really super smart, and the other end is you can work really hard. I was on the latter end of that, but most of you will be somewhere in the middle. So just kind of, it's more work in some ways than what you're used to for a course, but because it's hopefully in an area that you're interested in, it's more fulfilling and rewarding. So I think that will help out. So anyway, that's kind of where I'm coming from. And I worked in industry after I finished grad school. I actually worked on devices for people that were visually impaired. That was very rewarding. And then I went back to academia and did a number of things. And now I'm here talking to you as a lab director and safety coordinator. And so this is an area that our university is just, in our department, is just building up, because when systems design started, a lot of the things were mathematical, computer programming. Safety wasn't a big issue, but now there's a lot of things in the department that actually can hurt you. And so we need to really approach that kind of thing. Now, I wasn't here when this was done, but systems design used to have a course where they would go in a long dark room. This was in the physics building. They would set up a piece of fruit just like that. They would have a rifle. They would have a strobe light. They would have a camera, and they would take high-speed photography of shooting this bullet through whatever you're shooting it through. And I knew someone that took the course, Paul Kellerman. They had no safety goggles, no hearing protection, no training on the rifle. And when it was fired, the room was absolutely dark. So that's like the extreme end of, okay, this is kind of the antithesis of safety. And surprisingly, no one ever got hurt, and they canceled the course because it was too expensive to process the film. Because when you're running film like this, you're going through hundreds of feet of film, and that was in the old days. So now we want to shift to the complete polar opposite of that. We want to be as safe as possible, and we want to engender good habits that are things that you'll take from here and find useful in your whole life and impress your boss wherever you are. Now, our department now has a number of things that are much different from what it started with, nanotechnology and MEMS. These are very interesting areas, and one of them in particular, nanomaterials. Some of that stuff is pretty scary because these tiny particles, if they're in a powder form, they can enter your body and nobody knows what kind of the result of that will be. So these are things that we need to have special protocols for. There's lots of biohazards in our department because systems also developed another program, biomedical engineering. So there's tissues, blood, things like that. So things that can potentially have pathogens associated with them. There's x-rays. Some people work with live animals. I bet at least once a term, I get a report where somebody got bit by an animal. It's okay. So they're mice and rats, and they didn't lose a finger or anything, but it just happens. In fact, I just recently had a tour of the animal facility. There's an animal facility on campus where they have mice, rats, bunnies. Actually, when I went in there, we were with a group of people, and this large white rabbit just walked by where we were. Said, "Oh yeah, that's Stanley." And it's just one of the animals that they didn't have to destroy, and so they just keep them around as pets. So it's kind of interesting. There's robots, drones, AGVs, all sorts of interesting things going on in the department now. So it's come a long way, but it means all the more we need to have some kind of protocol for safety. So our first maybe line of defense is we do have a safety manual. And if you look on the main departmental website, right at the top, there's a link for health and safety. And if you click on that, at the bottom of it, you'll see this bar, and here's where the safety manual is, and that's what the URL for it looks like. And it has sort of the basic information that we really want you to know. These are just the general topic areas. You might think it reads a bit like a phone book, and it does to some extent, but it's really important. So even just chapter 2, roles and responsibilities, if you as a student, if you're taking a course and there's a lab and something goes wrong, who's responsible? One thing to keep in mind is that no matter who on the top end is responsible, you want to be responsible for your own personal safety. So you always want to err on the side of safety versus taking a risk just to do something faster. But it also tells kind of who to call if something goes wrong. Like even though you should have the training for this, if something spills, what's the proper way to clean it up and get rid of it? You need to know things like that. If there's a fire, what happens? So fire, you think, okay, a lot of labs have fire extinguishers. It's not mandatory that labs have fire extinguishers. Fire extinguishers are where? Well, they're in the hallways, and the labs can or cannot have fire extinguishers. It just depends on what lab it is and if the supervisor wanted one or not. One thing to note for sure, if you were working in an area where there's a lithium-ion battery and the lithium-ion battery catches fire, you don't want to try to put that out. The vapors from lithium-ion batteries will kind of melt your lung tissue, so you just want to leave if that happens. So just a small note. The one that I've highlighted, number 7, mandatory safety training. This is something that everybody has to take that's here. And I'll go over what that is in just a second. And then just general safety practices for being in a lab for any of the courses that you take that will be labs. Field work risk management. Yeah, correct me if I'm wrong. I don't know if we have any grad courses where students go out somewhere to take measurements. But that's what it's for, so probably won't apply to many. Maybe it becomes a gray area if you, for example, if you go to a company to do some work for them, it's like field work. It's similar but different, so you kind of have to. Yeah. Oh, okay. All right. So the training that all of you have to take are these 3 courses. The safety orientation, I know it says employee, but you're required to take it as students. There's workplace violence, because, okay, I talked about things that in the lab can go wrong and that you would, maybe have some dangerous chemicals or nanomaterials or something like that. But workplace violence, that's where, we're dealing with macroscopic things like the person working beside you and, you have a bad rapport or something like that. You need to know how to deal with things like that. And then WHMIS, I suspect a lot of you have had WHMIS training. WHMIS, they're still operating with WHMIS 2015. WHMIS has, I think, a 5-year expiration date. So I think they effectively updated it to WHMIS 2017, but it's really the same thing. But even if you took it somewhere else, you have to take it here. We have to have a record that you have this kind of training. And if any of you are supervising other people, like if you were a PhD student and you're supervising a master's student, you would need to take this supervisor orientation training. Now, for those of you that are actually working in research lab that has chemicals or different elements in them that could be hazardous, there are a lot of lab-specific, hazard-specific training modules. Your supervisor will have to tell you the list that you need to take before you can even go into their lab. So this is something that the supervisor should make absolutely clear. So depending on what kind of modality you're in, these are most of the courses that you might be taking. Sort of on the final end of things, the department does have a safety committee. I'm the chair of that committee, and there's a couple faculty members. There's a postdoc. There are 2 graduate students. Well, actually, we only have 1 graduate student now. If any PhD students are interested in being on the safety committee, I'd be happy to give you an opportunity to be on the safety committee. And part of what we do is look at policies and procedures in the department. We advise people if something new comes in that's not clearly defined on how they should deal with it. And we also do inspections on labs just to make sure that things meet the requirements. One thing, if you're in a lab, one of the things that the university is really clamping down on now are electrical certifications that have a Canadian certification or a field certification on them. And there's a number of things in our department that don't meet that spec, and we actually have the right to pull the plug on it or even cut the plug off if it keeps being used, because without the Canadian certification on it, there's a liability to the university if something goes wrong, even if that thing is misused. So we have to be careful. And sort of the last thing to think about is that we're really trying to engender the culture of safety. We want everybody to learn here and go from here and err on the side of safety. And it's so easy to take shortcuts. Just, I think about 2 months ago, I got an incident report where someone was cleaning a vessel that had blood in it, and they were cleaning it with some diluted bleach, and they weren't wearing any PPE. And as they were 2 things, they were cleaning it improperly, and they weren't wearing PPE, and some of this bloody bleach splashed on their face. So what do? Whereas if they were doing the protocols properly, they would have been wearing safety goggles at minimum, and they wouldn't have been cleaning it the way they were doing it, but they were taking a shortcut. And so we just want to make sure that you end up having the correct habits. So that's all that I have to say. If anybody has any questions, please let me know. All right, thank you.
Thanks so much, Eric. hope that gave you a little bit of an exciting look at the things that are going on in the department as well. There's lots of interesting research happening and things you'll be learning about in your courses too. So now, standing up at the front with me, we have Andrea Milne, who is our department liaison librarian. So she is an excellent resource for you. And if you're doing any writing, research, you name it, sorry, there we go. She will be an excellent resource for you to connect with during your time here. So thank you, Andrea.
All right, yes. So now for something a little bit different, or perhaps completely different. So good morning, everyone. As Anna said, my name is Andrea Milne, and I am the liaison librarian for the Departments of Systems Design and Biomedical Engineering. It's just my outline there if you're looking at it later. So who am I? So I have a Master's of Library and Information Studies, and I am your liaison librarian. You can contact me if you need help finding resources like journal articles, ebooks, maybe you're looking for standards or patents. I can help you with all those things. I can help you access those things because sometimes it can be a little bit tricky, especially if you're working from home. Also, if you're perhaps asked to do a scoping review as a part of your thesis or dissertation, I have a long experience in that sort of methodology of research and can help you with that as well. And also, if you have questions about open access, copyright, or research data management, I'm not necessarily experts in these areas, but I do know who to contact within the library who is and can answer your questions. All right, so finding some resources. The University of Waterloo provides quite a wide range of resources for free for you to use. And I already kind of mentioned most of them, like ebooks, e-journals. We have physical books still and much more. We also provide workshops and provide a variety of research help. For example, again, if you're interested in doing a scoping review as a part of your background for your dissertation, we are actually doing a workshop series on that sort of methodology starting in October. So there are two main libraries on campus. There's the Dana Porter Library, which is that big giant cement cube, and that houses the resources for the arts, humanities, social sciences. They have government documents there. The geospatial center is there, which might be of interest depending on what sort of data you need. And then there's the Davis Center Library, which is the library that's just across the railroad tracks. And it's the big sort of glass structure with the red pillars. And that's where I'm located. And that's also where you're going to find your resources for engineering, science, math, health sciences, etc. And there are actually also a number of other libraries associated with the university, although you may not necessarily need to use them. So this is our main website. When you first go in, if you haven't already checked it out, this is what it looks like. There may be some sort of notice up at the top. But the big thing I want to point out to you on this slide is that you can access the library anywhere. So that's whether you're on campus, in which case that you can just go straight into our resources. But also if you're at home, you're at a coffee shop somewhere, you've maybe gone somewhere for the weekend and realize you need to do a little bit of research on your weekend off, you can do that anywhere. And the way you do that is you just go into the library website, you want to access the resource, you'll click your link, and then you'll be prompted to enter in your What I Am account. So that's like the beginning part of your email, your password, and now we do the dual authentication as well. So you do those things and then you're in and you can go ahead and view all the ebooks, PDFs, whatever you need. So again, if you want to start accessing the library, it's right off of this page and you can start with the search bar. You just enter in whatever your search is and then it will take you into the catalog. Once you're into the catalog, you can start to filter your search based on what you're looking for. But the other thing I'm wanting to highlight here is we have an Ask Us feature. So this is where if you maybe have a question about where to find something or whatnot, you can enter your question into a web form there, which will then get sent to the staff member who's best able to answer your question. We also have a chat feature. So if you hover on the page for more than a few seconds, a chat bar will pop out from the one side of the screen. And this is actually connecting to an actual live staff member, no chatbots, it's a real person, and they will do the best to answer you in live time. So these are generally good for like shorter questions. So in terms of actually accessing your resources, we do still have physical books. I don't know if any of you still might need a physical book, but you can find them in the library. When you find a book you want to use, you'll see this sort of record pop up, and it'll tell you right at the top if it's a physical item or if it's a PDF, HTML, etc. And then down below under the Get It heading, it'll tell you where to find it. So this example, it's showing that it's at the Dana Porter Library. But then what's important to note too is that it's showing you that we have one copy and it's available and there's 0 requests. I was actually on chat yesterday and someone was asking me about a bunch of books that they were all out on loan already. So our loan period is 4 months, so basically the semester. However, if you want to recall a book, you can request it. And it just sort of depends, I guess, on the speed of the other person in terms of how quickly they'll return it. But that's sort of physical books. And also, if you're not sure where to find the book, so the Dana Porter Library has like 5 floors of books. So there's a locate button that will tell you where to find it too. And then in terms of ebooks, there's a couple of different ways. So ebooks, e-textbooks, like reference books, etc. You can either find them through the catalog, just doing your search, and then you put in that you want books that are available online and that you're looking for books and ebooks. Or you can also go to databases. We have a variety of databases that actually just contain ebooks. So there's things like Springer ebook. There's Novel, which is a good technical and data reference where you can find property data and all kinds of stuff there. And then there's Access Engineering. So lots of different ways to find ebooks. One of the other things that the library offers is we have what are called research guides. And there's a research guide for every department in the library. So there's one for systems design and there's one for biomedical engineering. They're fairly similar, but there may be a few small differences here and there. But they also have guides for things like copyright, for research data management. I know we have one on generative AI. So these are sort of guides to the library for you. So this research guides will help you find databases. They'll help you find websites that might be of use. We also now, all of the departments have a research guide related to Indigenous knowledge of some kind that's related to your field. So we have a whole guide on Indigenous people and engineering. And there's usually also links for writing and citing help as well. So I just want to highlight one more specific thing related to the engineering research guide, and this may be useful to you as you're going through and writing papers, projects, theses, etc. And you need to find some literature to back up what you're saying. This is the page here, the Get Articles, Reports, and Data that will lead you to our databases. So I've highlighted, we have all kinds of databases, and I've highlighted the ones that I think will be of most help to you as an engineer. So that's things like IEEE, Scopus, Web of Science, etc., along with lots of others. If you're in biomedical engineering and maybe you're working on developing some sort of device, you need to make sure that you're following the regulations set out by the Government of Canada. There's links to that. We also have a number of databases where you can find data sets. These days, a lot of the funding requirements are that once you've done your research, you have to make your data open. And so you can also find a variety of data sets and all kinds of different topics, which you can find through the links on this page. Some of the other research guides I wanted to highlight that may be of help to you there's a patents research guide. This is created and maintained by a different librarian, but you would still come to me first as I'm your liaison librarian. I know that patents are kind of a different type of information. They're typically housed in different databases, and they can be kind of tricky to find because they're typically not they're not filed under the name of the invention that you're maybe trying to look up. So you have to kind of be creative in terms of how you look for your patents. The other thing that I know engineers use are standards. And again, you see a different picture of a different librarian. That's the person who maintains this guide, but you would still come to me first. We have a wide variety of databases that link to standards. We use TechStreet, IEEE again. We have ASTM Compass, as well as the Canadian Standards Association. Lots of different ways to find standards, although standards are very expensive to maintain access to, so our access can sometimes be limited. For example, I know we don't have a lot of ISO standards, but you can sometimes find BSE standard or British standard equivalents that will give you the same information. And I just always like to highlight Google Scholar. I know a lot of people like to use it because it's quick and easy. I just want to say that use it with a grain of salt or use it with caution. Google Scholar is still a search engine, as is Google, whereas scholarly databases are different, and that scholarly databases have an editorial board who chooses which research journals are going to be included in that database. So there's already sort of a base level of check that you know that the information you're getting out of a scholarly database from the library is good information, or that at least someone has said that it's good information. Whereas with Google Scholar, all you have to do is email the Google Scholar team and say, hey, I have a thing, please post it in Google Scholar. And then they do. So there's just sort of that check there. And I want to really encourage you that you go to our databases. But if you don't, you know, I'm not going to stand over you and tell you that you must. If you're going to use Google Scholar, make sure that you link it up to the library. And there's that information there on how to do that. You can go into the settings section of Google Scholar, and then you can choose library links, and then you can choose to link the University of Waterloo Library to Google Scholar searches. So at least that way, if you find an article in Google Scholar, you may be able to access it through the library rather than getting hit with a paywall, which can happen if you're not connected. And the last thing I wanted to highlight is citation and reference management software. Especially if you're just starting your master's or PhD, you really want to keep your literature organized. So the University of Waterloo supports RefWorks, and we have an institutional license for Zotero. So Zotero is actually an open source, or it's open software, but if you use your UW email to sign up for an account, then you actually get unlimited storage, and you can keep thousands upon thousands of PDFs there, which is just sort of a nice little added bonus. Both RefWorks and Zotero also offer plugins to your word processors. So if you're working on your articles, your papers, what have you, you can insert your citations as you work on it, and then you can generate your reference lists after, which can be a big time saver. You don't have to do it manually. And if you go back and edit your paper and shift things around, it'll automatically align things so that you're, again, not having to manually check everything. And there's also, again, hundreds of different citation styles. So if you need to use IEEE or APA or what have you, it has all of those already loaded in. So again, I just want to reiterate, I am here to help you. So if you need help with research, figuring out where to look, how to look, I'm here to help you. You can always just use the Ask Us service if you need a quick question, or if you have a quick question that can be answered over chat. But if you need a real in-depth research help, feel free to contact me. My email is up on the screen, but also if you go to the research guides, I didn't highlight it when I had that picture up, but on the main page is a picture of me, and then there's two buttons, one for email me and one for book a meeting with me. I'm typically on campus on only Wednesdays and Thursdays, but I'm always available over Teams, like MS Teams or Skype, and we can always email whenever necessary. Do I have any questions about the library? Yes.
Can you expand a bit about the patent sessions from the library?
So yeah, we don't. So from my understanding is that if you really, really want to commercialize your product, you need to actually go to an actual patent lawyer, get a professional patent search. And I believe it's something that you actually get certified for, and I'm not certified for. But I can help you if you're just doing sort of background research, you're trying to get a lay of the land in your area, and you just want to see what sort of patents are out there, then that's something where I can help you a bit more with. There are a number of websites that you can use. There's lens.org. I know there's the Canadian Patent Office. I believe there's a Google patent search option as well. And in that case, either you can use the research guide to try and figure out how to do that, or I can help you. Because I know it can be a bit trickier because, like I said, things aren't typically patented under the thing that they're sold by. So you have to be more creative and use other keywords, or you need to find industry codes and things like that to search. But if you're looking to commercialize, you do need to get a professional search done because you don't want to infringe on someone's copyright. Anything else?
Thank you.
All right. You're welcome.
Perfect. So next we'll be hearing from one of our own graduate students, Asher Bad, who is one of our GAA rep or GSA reps, and we'll be talking to you a little bit about student life on campus and how to get involved. Get that started for you. Sorry. Perfect. There you go. Thank you.
Thank you. Hi, my name is Asher Bhatt, and I'm a PhD candidate. I'm currently entering into my 4th year. I did my bachelor's in India and my master's in University of New Brunswick, and now I currently am finishing my PhD, but I am a member of the SYDE GSA, the Graduate Student Association, and I'm going to talk a little bit about that. And so this is our team right now. So currently, these are some other students who are part of the GSA as well. So what's the difference between the university GSA and the SYDE GSA? So university GSA is a bigger organization, and it has all their departments, and it has a lot of staff there, and like student staff, I mean, and it's a bigger body, and it has a lot of services. I have put some pictures, and there is a website specifically for all these resources. But the SYDE GSA, on the other hand, is a much smaller community. It's only for the system design department. And because it's a smaller community, we have a closer interaction. We get to know who our faculty members are, and like the other students who are in the department as well. We also have a webpage, which I have put it here. I think we're sharing the slides. Okay, great. So you can take a look at our webpage as well. So what are some of our roles? So we are kind of like a voice. So for example, you might come across many concerns as a student, like for example, like as an international student, you might have a lot of issues. There might be like your funding issues, funding doesn't come on time, or you are not aware of the TA workload or any issues that you face. You can always reach out to the department, or like, like department processes a lot of requests. And to fast track that, you could reach out to the GSA, and one of the GSA members might bring it up to the department if needed, right? So it helps kind of fast track things a little bit. Also, we like to organize socials and recreational events, and one of them is today as well at 4 p.m. So I hope to see other students at that time. I'm going to announce that at the end as well. So we try to do at least 1 or 2 socials per term. And this year we have done 2, I would say 3 already, and this would be our 4th. And it's we promote exchange of information between students across different labs. So there are some information that some students know from, like, and that helps you, like, through our socials, you get to talk to them, you get to know more about them. And if we know about it, we also share with the other students. We also organize some academic events. So this year we organized along with the department, we organized the SYDE Symposium, which is a yearly thing where everyone gets to present their research. If you're a MSc or PhD, or as an MEng, you can also, another event we organize is the SYDE Seminar Series, which is like 1 seminar per month, which will be announced as well. So as an MEng, you can also participate in that and try to present. So this is like a social event where you present, but you also get asked questions, and it also helps bring like-minded or like students who are researching in a particular area to reach out and discuss your ideas. So how to get involved with the GSA? So like I said, so these are some of the events we did this year. One was a SYDE Symposium. We also celebrated a Pi Day. Pi Day is like 14th or March 14th. We got pies, and it was a nice hangout between all of our the SYDE Grad students. We also did a dodgeball event, which was really fun. And this was in summer, like I think 2 months ago. And today we'll be doing the SYDE GSA hangout at 4 p.m. where you actually get to meet the new students. So we also invited the current students as well. So there will be some new and some older students as well. So you can obviously get to meet a lot of people. And if this is something that you like and you would like to like join or something, then you can always like reach out to any of us. You can send out an email on this email, which is provided here, or you can send out an email to any of the current members. Also, like, as you take part in any of these events, you get to meet more people, and like that's how you can like contribute. We also are like an executive body, so we do hold nominations and elections. But I think the easier or the first step would be like to reach out and say like, hey, like this is something that is very interesting, right? And so what are like some of the events that happens at Waterloo, like, and how do you get to know about them? They send out email announcements. There are some Instagram IDs here, which if you follow, you would get a lot of events happening like every other week. Like you would get to know about them, and this is how you can get to meet more people as well. And there are some more opportunities to get involved. So there are clubs. So you have to look up clubs, Waterloo, and there are a lot of clubs apparently. And there you can get to, they have their webpage and you get to see a lot of information on them. I didn't provide links here, but these are very accessible. And then there is Women in Engineering. They recently, and like the department sent out an email. I think there is one event happening on September 18th where there is a roundtable talk, and you can obviously attend that and get to know more about it. And for volunteering, the department constantly needs help, like student representatives and things like that. If you get an email, you can always volunteer, and that's how you get to like meet more people as well. So tips for the new students. These are my tips, but obviously you can get more tips as you meet. So I would say you should say hello to your program mates, whoever is in your same program, or if you're in a lab, you should say hi to them so you can obviously get to know more about like more tips as well from them. So we do weekly socials on 3 to 4 p.m. So this is happening on the 6th floor, and Anna is the main person who organizes this, but it's really fun, and like we come for an hour, but like we get to hang out with friends, and there is always tea and coffee and treats as well all the time. So it's nice. And as I don't know if you guys already knew about this, winter here gets really cold, so it's nice to be prepared. So during the fall, you can try to prepare for it and arrange some winter clothings. And yes, while fall is really nice, I think it's important to explore the campus, see the facilities they have. There are gyms, there is the grad house, which is a really nice place. And there is the Student Life Center, which has a lot of offices. For example, like there's the bank, there is the pharmacy there, there's the bookstore there, and then there is the health center as well. So it's nice to explore that as well. So you know where to go if something like if you fall sick or something happens. And that's all. And see you today at 4 p.m. if you guys can make it.
Thank you so much.
Any questions?
Yeah. Feel free to use the washroom or anything, and then we'll be right back with Renata Donovan.
So my name is Renata Donovan. I am the Community Wellness Officer for the Faculty of Engineering. Not as sexy as it sounds. And I'm also a fellow student. I am a part-time PhD candidate in the School of Public Health, and I am researching student mental health. So it's my world. I love it. And I'm really glad that you're here. And I can definitely share a few things about being in grad school, especially working full-time and being in grad school, if any of you happen to be in that boat along with me. It's a lot. So let's just say that. So I did want to share with you, I don't know if anyone has told you about the WattSafe app yet, have they? Anyone told you about it? A couple people are nodding. Okay, so WattSafe app is the University of Waterloo's app, hence the name. So anyway, the thing that you may find the most interesting about this map, or this app, is the one here that says Campus Map, to help you find the nearest coffee and all the other fun things on campus. Other thing is you can direct call services right through the app. So if you need to find something, you can just click on the app. And in addition, and it's become a little dicey to say this after our June situation, if something happens on campus, they notify us through the app. That was the problem, it didn't work. They have since fixed it. So they'll tell us like stay away from a certain area. And another very important thing, if the university is closed due to ice storms in the winter, which tends to happen at least once, they will send a notification on the app. So you can go and you can check if the campus is open without having to go to the website and not come all the way down here, dangerous ice storms, to find out we're closed. So that's a good thing. So it's, it also has a whole bunch of other resources and things in it. So I do encourage you to take a look. Love the app. It was created by our, students and stuff. So it's got some limitations, but love the app. Okay. So the American Psychological Association did some research on what makes people successful in grad school. And if you notice from this, IQ was number 6. IQ, intelligence, was not the #1 thing that made people successful. Okay. It always makes us ask the question, because every year we see the some very highly intelligent people lead programs or fail different things. And so they've asked a lot of questions around if it's not intelligence that guarantees your success as a grad student, what does? So you'll notice that the first three are personality traits. The people who are curious, conscientious, so they have self-discipline, dedication, they focus on their schoolwork, set other things aside, sometimes temporarily. I'm always the one that says school is a temporary condition. You know, your program is 4 terms, as done. So there's certain things you may need to set aside, or at least partially aside for those 4 terms that you pick up when you're done. You're true, people who truly love you and care about you understand that this is a temporary thing, and as much as possible support that. I know that there may be times where it creates challenges with families. But generally speaking, there's very little we can't set aside temporarily. And confidence, believed in themselves. They knew they could do it even if they were struggling. And I had a similar experience myself. So my undergrad is in arts and my grad is in science. They are very different universities. Know that? So, you know, I got my first course, my first assignment back, and it was like 84. Okay, now, before you're impressed, in my grad program, is 75 is pass. The expectation is you're going to be in the 80s. Okay, so, but I naturally, without doing excessive harming to myself, I sit naturally around 92, 93. I can get higher, but what I have to do to get higher isn't worth the stress and damage it causes my life. So I comfortably sit around. So I get back and I'm like, what do you mean 84? Well, no, WTF. I get 93. Obviously, this prof doesn't know what she's doing. Okay, no, I got 94 in that program. This program requires something different to get 94. So part of what the first term will be for a lot of you is figuring out what is different to sit where you comfortably want to be. Okay, because it's not always about doing more. Sometimes it's about doing differently. It did take me that full term to figure out how to be in a science program and how they think, and all of the gaps in my science that I had to go backwards learn in order to do assignments successfully. Okay, so you could find some things like that showing up for you as well. So those 3 traits, but I was always confident I could learn it, even when I was struggling. Okay, and I had a staff score on my first test with like 34. I was like, okay, did everything you need to do, walked that course at the end of it. But yeah, but I believed in my ability to learn it. So that's going to be one of your number ones. Be curious about your subjects. Be conscientious. Believe in yourself. The next 2 is resilience. The ability to deal with setbacks, because there's going to be 1 or 2. As I've already demonstrated, there's going to be 1 or 2. And they could be in your personal life as well. Okay. So I had a situation last year where my husband was rushed to the hospital having a heart attack. Okay, I immediately put my PhD on hold. I took a step back. He's doing great now, by the way, fantastic. He's probably in better shape now than he was prior to. Of course, that's probably not a heart attack, but anyway, he's doing really great. So I'm back. I've got my ethics permission to do my research now. Okay, so that's part of resilience. Take the thing that comes, you deal with it, and you get back on track when you're ready and able. Try not to rush to get back on track. Doesn't always go well. And emotional intelligence, the ability to recognize our own emotions and regulate them. There will be moments of frustration. Okay, how are you going to shift that when they come up? There will be moments of joy and happiness too, as well. So lots of positive. I absolutely love my PhD program, even though it's so much work. So hopefully you're going to love your program as much as I love mine, because it makes all the work. Okay. So emotional intelligence, and that's also, and I saw some of you talking and connecting, positive relationships. We know that people have good social networks are more resilient and more successful overall, because on those bad days, there's someone to help you out. And I actually do a workshop on stress reduction that's coming up, protecting yourself from stress. You are all welcome to attend. And one of the things we talk about is know who your people are that help you with different kinds of things. So if you need to run errands, who can help you with that? If you're trying to figure out how to answer a certain kind of problem, who can help you with that? One of the things I would say on the list is know who the people who make you laugh are. Who can you have fun with and be silly with? Because on bad days, those people are everything. The last thing you want to do is talk to the negative Nellies on your bad day. Okay. When my husband was going through all of his stuff, I assure you, the people who made me laugh were the ones I called the most. Right? So that we could get through that time together. So know who those people are. If you're having a bad day, be super careful who you talk to. Okay? You can make it worse. And then IQ. Your subject knowledge. That's number 6. So hopefully it gives you some food for thought. I want to talk about a little tiny bit about stress, because it might be a little stress in grad school. A lot of people say to me, oh, there's good stress and bad stress. That's not quite accurate. The body actually cannot tell the difference between stress. It still reacts the way it reacts to fight or flight. But what there is a right amount of stress. Okay. And so this is the Yerkes-Dodson curve. Great curve. A few people have picked it up. And I'm sure you recognize the bell curve. You can be that entity. That's the bell curve. Okay, so you know that the middle section of the bell is what we're always aiming for. So what they've noticed is that when people are in that green section, that middle section of the bell, they feel motivated, they feel confident, they feel capable. They're what we call the window of tolerance. They can handle what comes at them and they feel good. When we have not enough, so we've gone to the yellow, not enough engagement, or too much on the red side, that's when the problems show up. Okay, so we saw a lot of the yellow during the pandemic. People were bored. There was nothing to keep them engaged. There wasn't enough stress, and that became stressful. Lack of excitement or stimulation in the environment. And then when we get into the red, we're in distress. So the goal is as much as possible, and it's easier said than done, to stay in the green. But certainly recognize when you've moved over to the red and what can you put in place that would help you get back to the green. Okay. The question I get asked often is, how do I know if I'm okay? People are never sure. They know they're kind of struggling, but they're not really sure if they've crossed the line. So this is one way you can tell. This is called the mental health continuum. There's a few different continuums out there. The idea is that the one that says healthy or green, that's kind of your, what is normal, happy, best day for you. Okay. The yellow reacting is like the equivalent of a bad day. So you've had a bad day, you go home, you use your tools, your de-stressors, and you're kind of back to yourself. That little purple line in the middle is when we have crossed the line. So usually the next one over, injured, is when that you cannot undo the bad day. So it's been going on, that bad day's been going on for 3 weeks. That's usually the time counselors say. If you've been really negative and not able to shift it, or whatever the concern is, any of those symptoms on there, and they've been going on for 3 weeks or more, and the people around you are starting to notice and ask you if you're okay, or they're telling you you seem really stressed out or whatever. You can't hide it anymore. That is what we have time for intervention. Okay, that's time to get some support, get some help. When it's all the way over to the red, people are not usually functioning very well. Okay. The thing I do love about this continuum is that wherever you are on the continuum, you can get back to green. But what I will tell you, and from personal experience, the farther over to red you get, the harder, longer, and more work it takes to get back to green. So it's much better if you can catch it in the yellow and orange and take action. Okay. And there's some suggestions down on the bottom. You'll get the slide deck so you'll be able to read it better. Some suggestions on things you might do. And there's a lot more things you can do that are not listed, right? But we really encourage, if you notice that you're kind of dancing on the line, that you move into action. Engineers are really bad for thinking that they're invincible, and that they're just going to power through everything. Some of you are laughing and recognizing yourselves. Okay, good. There are some tips on this slide for things you can do, because knowing the plan in advance, knowing that you're having the bad days may come up and knowing what might help in advance is great. So you can hang on to this slide and you can check it out and see if anything appeals to you that day. Haven't tried that one yet, okay? That thing that says big list of self-care that's in small letters, and that's a link to a really great resource sheet that counseling has created with a whole list of self-distraction techniques. So if you just need to state change, kind of like shake it off, that's not the same as making big systemic change, right? But just you need a moment, you need to clear your head. There's some really good ideas on that sheet. So check it out, download it, keep it for life. There's really good ones on there. We use a model of well-being that's called a dimensional model. It's the idea that we as human beings have different aspects of ourselves. And there's very similar to the Indigenous model. And so there's some suggestions in each of the aspects that are there. Okay. The one thing I'll mention about spiritual is it's not necessarily religious. It's our connection to life, feeling like it's meaningful. Why are we here? What's my purpose? It could be your creativity. It's how you express that kind of deeper part of yourself. And quite often when I talk to students who are distressed, it's actually that's the issue. I don't know why I'm going through all this. What is the purpose at the end, right? So it's got lots of things in there that can help you through. You really need to know your why if you're in grad school. Why did you want to do this? What was it going to give you? Very important. It'll help you get through some moments because it's going to be worth it at the end when I have that thing, right? And then we have some upcoming sessions and workshops that I already mentioned. The make your protecting yourself from stress, which I encourage you to come and join us. We're going to be we are starting a light therapy land program. I just have one little thing I have to work out before they're available. So for those of you who are not familiar with light therapy lamps, in the winter when it's dark, the lack of sunlight impacts our emotions. It can cause what they call seasonal depression, mood swings, sleeping issues. And it's well established now that certain types of light rays help counter that. So we brought some lamps in, they're here, but I just got to get a few things set up and you'll be able to borrow them for an hour, take them to your study area, sit under it for an hour, it'll help. If any of you are international students and you come from a country where the sun shines all the time, like around the equator, a lot of students that I've spoken to from different African countries, from parts of the Middle East where it doesn't really get dark, the days don't shorten like they do here. They didn't know seasonal affective disorder was a thing. And it's a very real thing in North America. So you may want to borrow those lamps because it's impactful. We're also going to have some cooking classes. If any of you have moved locations and now find yourself, the one coming up next week is with our nutritionist. We're not going to actually cook in that one, but she's going to talk a lot about how making sure your meals are balanced because there's a direct link between your mood and your success, your learning and nutrition. So hope you can join us for a couple of those. It's also really helpful to know where your resources are in advance. I'm not going to talk about every single one of them. One of the challenges on our campus is we have hundreds of resources. It can be very overwhelming to figure out what resources you actually need, right? So if you're not sure where to start with the elements. I'll just hone it right in for you, okay? If you go to our website, engwellness.com, or sorry, what are we? Engwellness at Waterloo? No. I lost it. The link is in there. Anyway, the link is in there. The one that says get help now website, there's a whole bunch of other stuff in there, but there's even more resources to help you get there. And you can email me if you're looking for something you haven't found it. You can email your departments, you can email me, we'll get you there. So these are on-campus resources. These are off-campus resources. So if you have a family doctor, there are people that don't. You know, if you go to your family doctor, you would not expect your family doctor to do open heart surgery in their office. You would expect your family doctor to refer you to a cardiologist and do the surgery in a hospital in a surgery suite. Okay. Family doctor has a scope in which they're very effective. The same is true for the university. We have a scope of supports in which we are very effective. When needs get outside of that scope, then there's community resources and medical system, public health resources that you also need to integrate into your system of health approach. So here are some off-campus supports for things that are more than we can support with, okay? And I assure you, it is a scope of practice and resource issue, not a desire to help with issue, right? But we can't do heart surgery in our offices. There's a limit to our scope. And that's it for me. So your resources are at your fingertips. Hopefully there's a few things to think about in keeping yourself well. And if you want anything on time management, you know.
Thank you so much.